So the next thing we'll talk about is the concept of oxidation numbers. Okay, oxidation numbers, also known as oxidation states. Okay, you can use them interchangeably. Okay, so if you look at this reaction that we were discussing, this reaction actually, we've given you ions. Okay, but normally we don't really deal with ions. What happens is we give you ionic compounds, and there are other species in solution. Out here, we did not care about the other species because they were not being oxidized or reduced. So we simplified the reaction and gave it to you. This reaction actually in reality would look something like this. Magnesium. So we need an anion to balance the copper 2 plus. So that would be 2 Cl minuses. So that would be CuCl2. And then out here, this would be MgCl2 plus Cu. So that would be what the reaction would look like. And one thing to note out here, notice carefully in these reactions, I'm not really specifying the phases because it doesn't matter at this point in time. We want just focus our attention on the actual species and not worry too much about if it's in the solid phase or aqueous phase, okay? It's not relevant right now for our understanding. All right, so now that we have this written this way, it's because the reaction is looking like this, it's hard to figure out what kind of form it has, if it's charged or not. Okay, so what we want to do is for oxidation number or states, we have to take, if we are given an ionic compound, we have to take the ionic compound and we have to write out the constituent ions. So this would have Cu2 plus and then 2 Cl minus. Those would be the constituent ions. And out here, this would be Mg2 plus and 2 Cl minus. And as you can see, because we have 2 Cl minus on both sides, out here we didn't care about them. Those were basically our spectator ions. We just eliminate them, and therefore we only look at the Cu2 plus and Mg2 plus. Okay, so when we look at Mg, Cu2 plus, Mg2 plus, and Cu, notice carefully that reaction was the first reaction we were discussing. So in this example, we're seeing it's very easy to map what just happened out here. Magnesium got oxidized, right? I'm going to write ox out there. And copper 2 plus got reduced. So I'm going to write reduced out there, okay? Consider another example, okay? Let's say I have hydrogen plus chlorine giving me 2HCl. So here I have a nice little reaction out here. And if I try to understand what happened in this reaction, it's going to be hard for me to figure out who got oxidized and who got reduced, because the H2 has a covalent bond, the Cl2 also has a covalent bond, and the HCl out here also has a covalent bond. Now it just so happens to be that this is a non-polar covalent bond, these two bonds, non-polar covalent, both of these. And this one actually happens to be a polar covalent bond. But even if it is a polar covalent bond, we don't know what the charge on the Cl or the H is, just like we knew out here to figure out who lost and who gained electrons. But turns out this is a redox reaction, but we just don't know the charge, so we cannot figure it out, okay? So in order to figure out the if any reaction is a redox reaction, irrespective of whether it's an ionic reaction or whether it's a reaction that does not involve ions, okay, we introduce the concept of oxidation numbers or oxidation states, okay? So let me kind of write out here what exactly an oxidation number is. So the oxidation number, oxidation state, would be a state where if all shared electrons, and I'm going to qualify this by saying all electrons or electrons in a bond were, because it could be plural, sitting on the atom that was more electronegative. So if we take the example of HCl, in this we have Cl and H. Cl is more electronegative, so we assume, and this is a construct, this is not a reality, this is a construct, so we can understand what's being oxidized and what's being reduced. So if we assume that the Cl was hanging on to all the electrons in this bond, then this could be written as Cl minus. And then the hydrogen would lose electrons, and therefore you would have H plus. Okay, so therefore we can see that the Cl gained electrons and a hydrogen lost electrons. So then it gets easier for us to assign oxidation number of states. Now, once we assign that, we can figure out if it's being oxidized or reduced. But in order to do that, we need to be aware of a few more rules that are going to help us understand how to figure out if something is being oxidized or reduced. Okay, and I'm going to go into these rules one by one.